So far we have rules that take us from the denial of a disjunction to something useful, from the denial of a conjunction to something useful, and from the denial of a conditional to something useful. All of these rules help us move through proofs efficiently, but we've got one more two-place or binary connective, and that's the double arrow. So we need a rule there. Now what we're going to prove here is one version of the rule, that if you have the denial of a biconditional, you can conclude the left side of the biconditional, double arrow, the denial of the right side plus an extra tilde. We could equally easily have proved it the other way. We could have proved that we could have the tilde here rather than here, and when we state the rule, that'll be part of the statement. But for the time being, we'll work through this proof and see how we can get where we need to go. So the first thing is, how are we going to prove P if and only if Q? Pause a minute and think about that. How should we go about proving that? Well, the best answer is to think about the fact that the way that double arrows normally get into proofs is by BD. If we can prove P arrow not Q, and if we can then prove not Q arrow P, a simple application of BD will get us what we need. So we want to use a conditional proof. In fact, we want to use two, one for each of the conditionals that we need. This is an assumption, in this case, for not Q. We're trying to show if P, then not Q. If we can then show if not Q, then P, we'll have what we want. But now we have a new question. How are we going to prove not Q? Well, we don't have any useful information extracting rules that we can apply. In fact, the whole point here is to figure out how to get line 1 into a form that might let us use IERs. When you're in a situation like that, and there's nothing obvious to do, that's the time to go indirect. So we will assume Q with our goal being to get to a contradiction. Now, how are we going to get the contradiction? Once again, we don't have any useful information extracting rules, but we've seen a number of proofs now where the way that these awkward things figure in the proof is as half of a contradiction. In other words, if we could prove P if and only if Q, that would contradict line 1. That would complete the indirect proof of not Q. Now, it might seem as though this would be very tedious until you remember something. We have a derived rule. We used it in the previous part of this lecture. That derived rule was arrow plus. And if you think about it, you'll see that arrow plus can quickly get us to both of the conditionals that we need. We need the conditional P arrow Q. How can we get it? We've got its consequent. And that comes from 3 by arrow plus. We also need the conditional Q arrow P, and that comes from line 2, since line 2 is the consequent of that conditional. So from line 2 by arrow plus, we have the other conditional that we need. You want to make sure that you feel comfortable about this. You want to make sure that using this rule arrow plus goes smoothly, because it's just such a tremendously useful rule. It just saves you a lot of time. So, we're trying to get a contradiction. The contradiction will be with line 1. That calls for a biconditional. We've got the two conditionals that go into the biconditional. We can write P if and only if Q on line 6. That comes from 4 and 5 by the rule BD. On line 7, we can write our contradiction symbol. Line 1 contradicts line 6. That means that we reached the goal that we'd set ourselves most recently. We got a contradiction. And because we assumed Q, what we will conclude is not Q. The justification is 3 through 7 indirect proof. Now, remember, why did we prove not Q? Well, we'd started a conditional proof. We assumed P, setting not Q as our goal. That means that we have now proved if P, then not Q. It might also help to remind yourself why we did that. By the way, I should have put scope lines in here. Let me correct that now. We need a scope line, and you can also see that I got a bit trigger happy here and should have unindented. Okay, so we got from P to not Q, unindent, scope line, we've got if P, then not Q. And the justification for that is 2 through 8 conditional proof. Okay? Why did we prove P arrow not Q in the first place? Because we were trying ultimately to prove P if and only if not Q, and we decided to do that by proving the conditional first from left to right, and then from right to left. Now, we've run out of room here. I'm going to leave it to you as an exercise. Complete the proof. You need to prove not Q arrow P. You should be able to do that pretty straightforwardly. Keep this rule in mind, but what you'll find is that you'll be using the other form of it. And once you get not Q arrow P, you can use the rule BD. But do go through the exercise yourself. Do actually complete the proof. Assuming you do that, we can now get around to stating the actual rule. The rule is called not double arrow. And what it says is that when I have not some double arrow statement, I'm writing it with P and Q, but it would go no matter what we had in place of P and no matter what we had in place of Q. Any well-formed formula here, any well-formed formula here. And the rule stated in one direction is that we can conclude P if and only if not Q. But, although we haven't gone through it, we could actually have also proved it in the opposite direction. That from P, if and only if not Q, we could conclude not P, if and only if Q. The useful direction is left to right. It's seldom that we would need to use the rule in the opposite direction, but it would be valid. You should prove it in the opposite direction. You should go through a proof to see if you can get this to work out. And this does require a little bit of ingenuity. I'm leaving it to you as an exercise. It requires some strategic thinking. But it's correct and it does work out. So this is one version of the rule. But what we said before was that the placement of that tilde on the right was actually fine either way. We could equally well have proved that from here we can get to here. And so that's another perfectly good form of the rule. Likewise, we could go from right to left. So this is our rule, not double arrow. Now, I really do want you to do two things. I want you to complete the proof that we saw on the previous slide and make sure you understand that. And then the rather interesting strategic task, you'll see that strategy is what you'll have to think about, of going from right to left here. Construct the proof from P double arrow not Q to not P if and only if Q, and make sure that you either get that to work out or get in touch with me and we'll think about how to do it. It is a bit of a challenge, but you can do it. Meanwhile, we now have rules that allow us to deal efficiently with any denied compound whatever, and that's a good thing. I'll be giving you some exercises that give you more practice just in doing proofs in general, but we've already set you some exercises here, so go off and do those.